P16, multiplying probabilities. The other day you did probabilities and you added them. And tell me about that. How many of the different ways, how many selections were made? Was there 5 selections? Was there 1 selection? Do you remember? There was an or, right? So if I said somebody came in here and randomly picked Emily or Ireland, right? And we added. But there was 1 selection, wasn't there? And there was different choices. You understand it? Well, we're going to extend on from that today when we talk about selecting something and then selecting a second time or a third time, okay? And so we're going to have a difference. You see the difference? One is we're selecting once, but we have different choices. This time we're selecting different times, so there's more than one possible selection. You understand what I'm saying? So the other day we talked about adding probabilities. Today we're going to talk about multiplying probabilities, okay? Because that's how you find out if there's more than one selection. So we're going to talk about 2 different events. The first one is called independent events. Okay? And the second one is called dependent events. Okay, so let's set up a scenario. All right? Let's say that we have I want to keep away from what they use. They use marbles, so we have a bag of marbles. So a bag of marbles contains 4 red, 7 yellow, 5 blue, 6 black. How many am I up to? 11, 16, 22, and 3 green. Okay? Find the probability of each situation. Okay, so a bag of marbles contains 4 red, 7 yellow, 5 blue, 6 black, and 3 green marbles. Okay, find the probability of each situation. All right. Now, how many total marbles are there? 25. There's 25 marbles. Okay. So what we want to do is we want to find the probability of pulling out a green, replacing it, then pulling a red. Okay? Now let's talk about this. Would this be an independent event or a dependent event? In other words, does the first selection have any influence on the second? It would be independent. What makes it so it doesn't have influence on it?
You replaced it.
We replaced it. We replaced it. All right. So in this situation, if we have the probability of A and then B, this equals the probability of A times the probability of B. Does that make sense? Okay, this is number 1, by the way. So what is the probability? So we're going to multiply that. We have 2 selections. What's the probability of pulling out a green, Bryant?
3 over 25.
3 over 25. Bryant, if I can simplify these fractions, should I?
Yes.
Yes. Whereas the other day when we added them, what happened when you simplified them? Oftentimes. Different denominators. So I advise you not to simplify them. today I'm advising you to simplify because then we have smaller numbers. Obviously 3 and 25 we cannot simplify. What's the probability then? Now we put it back in, right? What's the probability, Emily, of pulling out a red?
4 over 25.
4 over 25. And I don't believe we can cross cancel or cancel above. So on the top I have 12, on the bottom I have, I believe 625, is that true? 25 times 25?
Why did I?
Yes. Okay. All right. Okay. 2. What's the probability of pulling a black, replacing it, and then pulling a blue? Did you figure that one? Okay. What's the probability of pulling out a black, Izzy?
It would be 6/25.
Okay. Which can be not simplified or simplified? No. So we're going to take that times, what's the probability of pulling out a blue?
1/5.
1/5. We can simplify that. And you can't cross cancel, so we have 6 over
125.
125, right? Any questions? Okay, these are independent events. Let's try this one. What's the probability of pulling out a yellow, replacing it, and then pulling out another yellow? Emily, what's the probability of pulling out a yellow?
7 over 25.
Okay. And then we're going to take that times what, Ireland?
Same thing, 7 over 25. 2. No.
You all agree with that? Okay. And what do we get?
You get 49 over 600.
All right. Okay. These are all independent events. Right? Now we're not going to replace it. All right, let's go back through. This number 4, we're going to pull out a green. But can I just put not? Well, I'll go ahead and put not replace. And then we pull out a red. So now we're taking it out. We're not replacing it. These are dependent events. Why are they dependent? Why is this dependent? Or dependent?
Because
you're
there's
not
one less
replacing the
marble.
green.
Okay. The first go around, because you don't replace it, affects the second go around. Okay? All right. So what is the probability of pulling out a green? Maya?
3 over 25.
3 over 25. We're going to take that. Oh, by the way, what's the rule? This time, it's the probability of A and B. Same thing, right? Equals, and this book writes a little different than my last book. The probability of A followed by the probability times, probability of A times the probability of B following A. They put a line like this, which means the same thing, okay? So it's the same thing, only we just gotta take out a different number. So what was the probability of the green again, Maya? I'm sorry. 3 out of
25.
Now we're gonna take that times, what's the probability of the red?
1/6.
1/6, okay? The red is, okay, let's take a look here. The red is 4 out of 24. Why is it 24? Because
Because
we,
there's one less marble.
one less marble, all right? And we can cross cancel now, right? So I'm getting 1 out of 50, correct? All right,
Should it be, wait,
1 out of 50?
yeah.
Okay.
I knew it was.
What's the probability, let's take the same up there of black, not replacing it, and then go blue. Do that one, please. Ireland, what's the probability of black?
6 over 25.
6 over 25, cannot simplify that. Times, what's probability of blue? Bryant?
5 over 24.
5 over 24. Doesn't look like we can simplify that, but look at this. We can cross cancel this 1 and 4. We can cross cancel this 1 and 5. So in reality, it's 1 over 20. What do you notice about the probabilities of the dependent compared to the probabilities of the independent?
The independent are a lot larger.
The independent are a lot larger?
Yeah.
Okay. All right. Let's, in terms of numbers, yes?
You also normally can't cross cancel.
You normally can't cross cancel. What's the let's do number 3 then. What is the probability of a yellow not replacing it and then another yellow? Be careful. Okay. Ireland, what's the probability of yellow?
7 over 25.
7 over 25, but what do we multiply it by?
6 over 24.
6 over 24, which happens to be
1/4.
1/4. Why 6 over?
Because you have one less yellow.
You have 1 less yellow, so the numerator goes down 1, doesn't it? Okay. Cannot cross multiply, so I'm getting 7 over 100. Is that correct? Okay. Do you see the difference between independent and dependent? Okay. Now we are going to skip over conditional ones. I didn't think that that was probably something that you would see a lot of. So your assignment is, Maya, would you write this?
I think it's already up there.
No, I changed it.
Oh,
Okay, I changed it. So it's, I guess Maya doesn't want to do it, so I'll do it.
okay.
Maya, get over here and do this. Alright. Because I gotta read it. That's the only reason I have it. You just don't want to be in the video. 1 through 6 and 11 through 14. So very short assignment. You have today and tomorrow to work on it. And they'll watch the video. So
Is it
would you shut her down?
OPP 19?
It's